Another curve graph in hydrology uses the moving average method. This video answers what this is and how it proceeds. You are in hydrology. The moving average approach is a statistical method of identifying a trend. In hydrology, this is used in order to show the cyclical fluctuation of precipitation. And since trends can be shown in cycles, ample number of data is required. The parameters needed to draw this curve are time in years and the depth of precipitation. There are two options in doing this method. One is the 3-year term and the other is the 5-year term. Using more coordinates, the 5-year term is more accurate. Let's check this example to understand how to go about this type of curve. The problem contains a record of rainfall in a certain catchment area from 1980 to 1999, exactly 2 decades. The rainfall observed is in centimeters. We are to illustrate the moving average curve to see how storms occur. The first step is to create a bar chart where the abscissa is time in years and the ordinate is the rainfall in centimeters. The chart is divided into the yearly record or 1-year interval. The first bar at 1980 is 50 centimeters, followed by 60, then 40 and 30 centimeters. The precipitation starts to rise again with 35, then 40, and a small spike at 65 and 60, to go down to 40, then rises again at 55, then 50 centimeters. Then in 1991, the precipitation is 60, which goes down to 55 and 45, then to 40 and 30. Then starts to rise again to 45 and to 100, with 90 and 50 centimeters. With the numerous bars, the computation starts by isolating the first 5 years and taking their average. This average is placed at the mid-bar. Take the average rainfall depths of the first 5 years. That is a fifth of the summation of 50, 60, 40, 30, and 35. This is 43, and place it by the 3rd year of the group. Move a year after, and compute for the average of 60, 40, 30, 35, and 40, which is 41. This is placed at the x distance between 1982 and 1983. Another year further, take the average of 40, 30, 35, 40, and 65, and it is 42. Place the point between 1983 and 1984. The next 5 years have rainfall depths of 30, 35, 40, 65, and 60, and their average is 46. This point is placed between 84 and 85. The next group has precipitation depths of 35, 40, 65, 60, and 40, having an average of 48, pinned between 85 and 86. Moving on to the next 5 years, the average is computed as a fifth of 40 plus 65 plus 60 plus 40 plus 55, which is 52, drawn mid-86 and 87. A year more, then get the average of 65, 60, 40, 55, and 50, which is 54. This is placed between 87 and 88. For the next point, the average of precipitation is solved as a fifth of 60 plus 40 plus 55 plus 50 and 60. That is 53, pinned between 88 and 89. For the next 5 years, the depths included are 40, 55, 50, 60, and 55, and their average is 52, pinned between 89 and 90. The next takes the average of 55 plus 50 plus 60 plus another 55 and 45, which is 53, found between 1990 and 91. The succeeding pin comes from the average of 50, 60, 55, 45, and 40, which is 50, placed between 1991 and 1992. Almost at the end, so let's keep on averaging. The next batch takes the average of 60, 55, 45, 40, and 30, and that is 46, placed between 92 and 93. For the pin between 93 and 94, the depths to be averaged are 55, 45, 40, 30, and 45. The next 5 years receive precipitation of depths 45, 40, 30, 45, and 100, where the average is 52, placed mid 94 and 95. For the point between 95 and 96, take the average of 40, 30, 45, 100, and 90, which is 61. The last point to complete the series is taken as the average of 30, 45, 100, 90, and 50, which gives 63. This is pinned between years 96 and 97. Connect these points to complete the moving average curve. Notice the trend of going up and down like a wave, making it easier for the interpreter to forecast the next occurrence or frequency of rainfalls.